Okay, so this is just a quick mini lesson on solving matrix equations. Now, this will work for a 2x2 matrix, which is what we have. The setup for this particular matrix is AX equals B, where the first matrix, the one that's next to the variable x, is A, and then the one on the other side of the equal sign is B. Now, in order to solve for x, x equals the inverse of A times B. And it's really important that you have the inverse of A listed first before B. Because remember, multiplying matrices, the commutative property doesn't apply to that. They're not commutative. So make sure you have the inverse first. All right, so the first step we have to do is we need to find the inverse of A. In order to find the inverse of A, you first have to find the determinant of A. All right, so in this problem, we just remember it's A times D minus B times C, so we have 3 times -5. And then we're subtracting -4 times 4. Multiply that out, we get -15 minus -16, which is the same as saying plus 16. So the determinant of A in this problem is 1. And it's kind of fortunate because that'll make the inverse part really easy. So remember, to find the inverse of a number, or excuse me, a matrix, it's 1 over whatever the determinant is, all right, times, remember inside these parentheses, you have to flip-flop where A and D was. Normally A is in the top left, but now it's going to be in the bottom right. So it's A is down here, and D is right here. B and C stay in their original locations, but you make them both negative or their opposites, depending on whether they're positive or negative. So for this problem, to find the inverse of A, it would be 1 over 1, because we just discovered that the determinant right here, the determinant of A was 1. And then I'm going to multiply to that. Okay, I'm switching A and D. So A is 3, that goes down here. D is -5, so that's going back up here. Now B was -4, so when I take the opposite of B, I'm going to have +4. And C is going to be -4. And I know it looks like I just flip-flopped B and C. That just happens to be because those two are opposites of each other. It's not always going to look like that. So now when we solve this, we have the inverse of A equals -5, 4, -4, 3. All right, so once you have that, you're a little more than halfway home. So now to solve the actual equation, okay, we're going to use this right here. All right, so to solve for x, we have the inverse of A. And in this case, the inverse of A was -5, 4, -4, 3. And to that, we're going to multiply matrix B. In this case, matrix B is 0, -22, 0, -28. All right, so you multiply those together. Now, the common mistake that people make is when they multiply the matrices after finding the determinant is they're so used to subtracting, because in the determinant it's AD minus BC. It's multiplying and subtracting, but when you're multiplying matrices together, you're multiplying and adding. So, solve for x here. Standard rules apply for multiplying matrices. We have 5 times 0, which is 0, plus 4 times 0, which is 0. And I'm going to do the lower left. So we have -4 times 0, which is 0, and 3 times 0, which is also 0. So 0 and 0 is still going to make 0. Now, when I do the -5, I have -5 times -22, and to that I am adding 4 times -28. So this right here, the -5 and -22 is going to give me 110. And then this over here is going to give me -112. So when I add those two together, I'm going to get -2. Right? And then for the lower right, I have -4 times -22. And then to that, I will be adding 3 times -28. Right, well, 4 and 22 is 88. And 3 and 28, well, let's see, I'm not sure, multiply that. So 4 and 2, we get 84. All right, so, but it's going to be negative, so we have plus -84. All right, 88. And -84 is +4. So the solution to this problem is the matrix 0, -2, and 0,